Hello, hi, this is Kale Kamal Mohan, and my research topic is automatic facial expression detection. The topics I will be covered in this are introduction, research question, relevant work done in this area, proposed methodology, model evaluation, risk and ethical issues identified outcome of project, conclusion, project work. The introduction. In my research, I would like to do my analysis on human image expression classification using machine learning algorithm. As you see here, there is a universal emotion types which are happy, sad, anger, excitement, neutral, etc. Whereas comes to the motivation part, it's more about human machine interaction. Consider yourself, you're sitting with a laptop with the automated expression learning algorithm, so that if you're sad or happy, based on your mood, the system responses, or if you play some songs or send you some jokes mail or something, it will be interesting. And the application keeps going like automatic face emotion tagging, robotic expression application, etc. The main significance of my research is like mainly to overcome the challenges we face in the deep learning. Already there are lot deep learning, there are a lot of approach carried away for facial expression detection. For all those deep learning, we need large number of images and higher GPU systems. My challenge is mainly to overcome the challenge of we face in deep learning, and also to measure the pros and cons of each methodology used so far in facial expression detection. And the last is like to propose the best feature extraction method along with the suitable machine learning algorithm. And why I want to go with the lesser images trend, as I said, to overcome the drawback of deep learning. And for there are a lot of research going in deep learning to identify the sex, gender and sexual orientation of the person. For everything there are lack of images, they are struggling with getting the images to train. Hence my approach will be greater help for impact for this kind of researchers. The general findings and reviews are to analyze the best feature extraction, dimension reduction technique, and evaluating the classification algorithm. Research question is to what extent the emotion of the person can be identified from facial image features using machine learning algorithm. I will just give a gist about my relevant work what is done so far. Literature. The feature extraction technique used is SAFT, which is scale linear transform, wavelet features, Viola Jones algorithm, anthropometric features. Feature reduction technique widely used are PCA, and classification algorithm so far used is SVM, decision tree, artificial neural network, and K nearest neighbor, and deep learning techniques such as convolutional neural network and deep sparse coding network. This is like overview of my literature review and how it has related to my work. The first, as I said, like what feature extraction technique it has used. These are the feature extraction technique, as I said. Here is the shortcoming of many authors have used Viola Jones algorithm, but there is a drawback because it involves many steps to achieve the feature extraction, and also it is more sensitive to the feature extraction. Whereas when coming to wavelet transform, even though it gives texture information by performing edge detection, it still lacks with distorted images such as person having different skin tone and aging factor. And there is some standalone anthropometric feature technique. Anthropometric feature technique is like all about human face ratios, like getting the measurement of the face. So it gives the unique features, but it still lacks with accuracy. Whereas in my research, I'm going to combine both the wavelet and anthropometric features, which is a novel feature extraction technique which I'm going to propose here. In wavelet transform, it is totally about, it deals with the pixel intensity of the images. So it will take the features from the pixel intensity, whereas in coming to the anthropometric features, it will take the human face ratios. We'll be seeing in methodology how it works actually. So about the classification, as I said, these are all the classification they use so far, and we can see the drawbacks here. Like for each and every, for the deep learning techniques they use, it's to extract high dimensional features, which takes longer time to train, and for conventional network it takes more layers. And from out of this, I have sorted out to use artificial neural network, multi-class SVM, and classifier, and KNN classifier. The reason why I want to use, I'll be discussing later. This are all, and this is how it related to my work. This is my proposed methodology: getting input of the image and pre-process the image, extraction of wavelet and anthropometric features, and apply the PCA dimension reduction, and train the features and model evaluation based on the test image. The model will be evaluated. Input the train image and pre-process the image. First is pre-processing is like histogram equalization, whereas if you have noise in the image, doing histogram equalization will give a proper image. Wavelet feature extraction. Wavelet feature extraction, as I said, it's totally based on the intensity. Once from the level 1 decomposition, they will be applying some low pass filter and high pass filter on the image so that the edge detection. will be getting, so that further applying to level 2 decomposition, still more information will be gathered. Based on this band of images, the wavelet features will be coefficients will be extracted, and which is nothing but wavelet features. This is all about the getting the texture and shape of the human image. These are the features I'm going to use. Along with that, I'm going to use anthropometric features. From the face, I am using the IF algorithm. I will be getting the landmarks on the face. For each expression, you can notice like there will be a difference in eyebrows and nose and mouth, everything. So I'm going to measure the distance, which is distance between eyebrow and eye, width of the mouth, height of the mouth, width of the nose, etc. So this information comes as the anthropometric features. So what I'm going to do is the combination of both wavelet and anthropometric features gives detailed information of image by overcoming the drawbacks on both standalone texture and anthropometric features. This is the novelty I'm going to bring here. And dimension reduction, as PCA has been used widely, so I'm going to use PCA for my extracted features. So coming to the classifier models, why I want to use a KNN here? Reason for choosing KNN is simplest. It is simplest and instance-based classifier, and also it applies very well for the numerical features. As I'm going to extract the anthropometric features also, so it is like a measurement. So I think KNN will work for that too. And also there are many researchers which has done KNN along with the wavelet features. So the combination will work for KNN. So I decided to choose KNN. Implementation of KNN is based on equidistance formula. This is explained very well in the documentation. Then why I want to use SVM classifier? The reason for choosing SVM classifier is like one among the best class texture classifier. As we are using wavelet features, SVM is the good choice. The implementation of SVM classifier is further discussed in the is more discussed in the document. Why I want to use the why to train the ANN model? Why I want to use the artificial neural network? As we all know, artificial neural network is well for spatial domain. Actually, I'm going to use the image which is in spatial domain. So ANN works very well for the spatial domain images, and also there are there are literature based on literature. I could say ANN has worked very well for wavelet features. So I want to use the ANN artificial neural network as I thought like ANN would be a good choice for using my project. And in ANN specifically, I'm using single hidden layer feed-forward neural network. And this is our architecture of single hidden layer feed-forward neural network. And this is the input layer, hidden layer, and output layer. And the model evaluation. The model evaluation is rolled out method. It's like 80% of the images I consider as a train image and 20% of the image as an my testing data set. Confusion matrix. Confusion matrix. As we all know, this confusion matrix and overall classification accuracy. Everyone will be all the authors will be using for classification rate and misclassification rate. Precision. How well the model is precised for particular label, particular classification. Why I want to use sensitivity and specificity. Sensitivity is more why I want to take the sensitivity here is like if suppose the model gives you the classification of face happy faces, instead of happy faces, if it gives sad image, it's like two extremes. You should not misclassify so extent like happy to sad or sad to happy. This will be from the application purpose it will be a total drastic change. So this kind of extremes, for this kind of extremes I will be calculating sensitivity and specificity, and also along with that I will be calculating F measure and ROC curve. Basically the what is the risk and ethical issues, as the project will be implemented many machines like automated machines, but all those will be for all those automated machines should be aware about the procedures and everything, because it's illegal to track the facial expression of the human image without noticing them. So it should be like proper procedure should be carried away. That is the ethical and risk here. And identify outcome of the project. This proposed wavelet features and the best model out of the three model I will be coming out of the best model. So the combination of the features along with the best feature classifier model, this research can be used anywhere for further classification for problems. For example, if consider like in lesser image, there are researchers already going on to find the sexual orientation, age and everything. So for this kind of all there's a lag of images. So my proposed algorithm will be used will very well for that. And along with the standalone that novel feature extraction method which I have taken out from the features anthropometric and wavelet, only this part can be used in many image classification, human image classification problems for sure. And here I will conclude like I have discussed my relevant work, proposed methodology, model evaluation, risk and ethical issues and outcome of the project very well. This is my project plan, and it has discussed more in documentation. Thanks for giving me the opportunity. Thank you.